So let's look at the light sources. The first electric light bulb, invented in 1851 on two sides of the Atlantic Ocean. Thomas Edison in the United States and Joseph Swan in the United Kingdom. Interestingly enough, uh, Thomas Edison's lamp wasn't that good, but Joseph Swan had in fact made a better product. Thomas Edison had lots of money, Joseph Swan didn't, and the two joined forces and formed the Edison Electric Light Company. We move on to the era of fluorescent lighting, and in 1926, that was invented by Jacques Rislier, a French engineer. And we know the effect that it had because fluorescent lighting was used extensively till very recently. In fact, it's still in use in many places. And then we go to the mercury vapor lamps, not exactly in sequence in history, because it was originally invented in 1860. High pressure sodium lamps saw the light of day, to use that expression, uh, in 1912. And then metal halide came about in 1962, much more recent. It was really commercially uh, implemented in the 80s and 90s extensively. But then, much further back in history, the LED, which we think is a modern device, was in fact invented by a Russian, Losev, who died, in fact, in the war, Second World War, in Stalingrad. And then it went on, and Nick Holonyak, who was working for General uh, Electric at the time, he invented the red LED. And as you know, many of you have had little CD disc players and so on. You would remember that there was a little red laser light inside. And that is all thanks to Nick Holonyak. And that was in about 1962. Let's move on to the more modern history now. We move on to light emitting diodes, or LED as we all fondly know it. The first modern LED was developed, it's a blue light, intrinsically blue light LED in its natural state before applying any uh, phosphors to it, was invented by a Japanese gentleman, Suji Nakamura, and it was shared with Alasaki Isamu and Ormano Hiroshi, all Japanese material scientists. So, as material scientists, they invented the LED using certain chemicals to create it. By 2010, the LED had reached the astounding efficacy of 100 lumens per watt. And everybody said, well, it wouldn't get much higher than that. Well, Philips broke through the 200 lumens per watt by 2015. But interestingly enough, good performance LED today is in 2024 delivers around 150 lumens per watt. The next technology we saw was power over Ethernet. We're going to speak a lot more about it this evening. It became commercially available in 2018. But it's interesting, I was in fact delivering workshops in 2015 already talking about power over Ethernet. And then along came Professor Harold Haas at the University of Edinburgh. He'd worked for a long time on this particular project, and he developed the visible light communication. as far back as March 2011. And he presented a TEDx talk when he showed off the first visible light communication using LED light. And we're going to talk about that as well a bit later on. Philips, in fact, also developed visible light communication using LED light in 2017. So with all this in mind, and we're talking about energy efficiency, one of the reasons that we want to do it, and there's this drive to do it, is because of the energy costs. If you look back at 2021, which is only 3 years ago, the cost of electricity supplied by our utility in South Africa was R1.23 per kilowatt hour. Now, at that particular time, it was a lot less expensive than overseas. Overseas markets were paying much higher costs for energy. And by this year, right now, energy cost is R2.61 per kilowatt hour. There are many tariffs because there's a lot of time of use, and it depends on whether you've got peak demand. So there are lots of variables in the cost. But through the experts and so on, I was able to ascertain that R2.61 is the current cost per unit or per kilowatt hour. So there's great motivation to save energy because it, in fact, helps our pockets. It helps big business pockets as well. So the continuous tariff increases is going to demand greater focus on super energy efficient lighting, the subject of this evening's webinar. So, out with the old and in with fourth industrial lighting technologies. And we're going to talk about new generation LED lighting. We're going to talk about power over Ethernet, Bluetooth mesh, visible light communication, and indoor positioning systems. Some exciting topics for this evening. But I want to issue a disclaimer right at the beginning. BHA Lighting does not sell lighting products. We are not linked or tied to any single product brand. We never compromise on quality for our clients. We are completely product agnostic. BHA Lighting applies standards judiciously, and the knowledge of standards, our knowledge of standards is excellent. And we use the highest international standards on which our standards and many other countries' standards are based. We not only know the tables that tell you what lux level you should have, maintained lux level, we also know the fine detail and the content within the standards. So let's look back in time in South Africa. In 2007, I can remember, and I'm sure many South Africans will certainly remember it, we were asked to take our old incandescent globes that we had in our light fittings at home to a shop, any shopping mall. And there was a table with Eskom staff, and they exchanged the incandescent lamps for compact fluorescent lamps, or CFLs as they are generally known. This was the first big energy saving campaign. To give you an idea, a 60-watt incandescent lamp was exchanged for an 8-watt compact fluorescent lamp. That was a saving of 52 watts. And if you work it out in kilowatt hours, and in those years, it was way less expensive for your electricity than it is today. But also consider this: 60-watt incandescent lamps consumed for that 60 watts, 80% was heat generation, and only 20% was the production of light. So there's huge wastage there. The energy anyway. They were inefficient, but at that time they cost very little, so they were very affordable. And I can remember selling incandescent lamps for Thorn EMI lighting way back in the 70s, and they were about 25 cents at the time. So really very affordable for everyone. So the next bold attempt to save energy by our power utility, known as Eskom, business was encouraged to change to LED lighting. And at that particular time, in the early days of LED lighting, there was a lot of reluctance to, in fact, change over to LED lighting. People didn't believe it was as good. At that, initially, it was quite a lot more expensive than a fluorescent tube, for example. And you couldn't retrofit LEDs into a fluorescent light fitting because the LED tubes were only powered on one side. So if you put it in, you could get quite a nice explosion if you applied the normal connections to it. So what did Eskom do? They offered rebates to encourage people to change over. The rebates meant that in most instances, and the hotels were amongst the first to become involved in this exercise, they were able to change all the LED lighting for a fraction of the cost, only about 20% of the cost. Eskom subsidized 80%. The main benefit to people who adopted this and went for this offer immediately made energy savings. They brought their energy accounts down, far down. So, an example: hotels changed their 50-watt halogen lamps, and there were hundreds of these things in lots of the hotels. They changed them to 6-watt LEDs. That's an 88% saving. They took the profit and it went right onto the bottom line. So it helped people some of these organizations and businesses and hospitality places to be very profitable all of a sudden. But there's another way that we can save energy without really doing much. If only everybody would know how the standard works. And if you use the international standard on which SANS 10114-1, the latest version, the 2020 version, is based. It's based on EN 12464-1, which is the international standard. There are 3 particular areas. The standards, the lux level in the standard, specifically addresses the primary task area. And the primary task area on most people's desks varies between 1/2 and 1 square meter. So that is that tiny, let me just get a point up. That is the area there. That's the primary task area. So when you talk about you need to have 500 lux on the task area, that's the area that must have 500 lux so that you can do your work efficiently. But this area, the secondary area, that area can be lit to 60% of the primary task area. So to make it very simple, if the primary task area had to be 100 watts, the area around it could be 60 watts. All right, just to give you an idea. Or 60 lux, not watts. Then this area, this greater area around here, is what they call the ambient area. And that area can be 20% of the primary task area, but not less than 100 lux. So if we apply our minds, there's an instant way to save energy by lighting spaces correctly. So, how much can be saved? We need to quantify it. You can save from 40% and more by doing correct lighting design. The best way, and really the only way, to achieve this when you're doing lighting design using software is to use Relux Desktop. It produces results based on the standards. You can set the standards in the software, as in the model shown in the previous slide. Previous slide, that one. So let's look at the first technology. The first technology we're going to look at is power over Ethernet. Why is power over Ethernet something that helps us to save energy? It's very simple. If you take an LED device, an LED light fitting or luminaire, it has a driver. Because we are powering it normally with 220 volts, it requires a driver to convert from 220 volts to DC current to drive the LED. Because the LED is a DC device, direct current device. So if we are able to cut out the driver for the operating of that LED, we are able to save the power that the driver would consume to drive the LED. So there's another area of saving. Now the beauty is we can power all of the lights, all of our lighting using Ethernet cables. The same cables that you supply or provide data with from computer to computer, from telephones. Telephones also use fiber nowadays over the Ethernet. Cameras, CCTV cameras, sensors, a variety of sensors, in fact, alarms can all be powered through a switch mechanism. This is a switching device. And there are various sizes, from small switching devices up to large ones. So, this is fantastic technology. So you can drive data and power through the same Ethernet cable that you use for your network. And remember, running computers on Ethernet gives you 10 times faster working than on wireless. Right? Fiber is faster than wireless, but fiber comes in and you still rely on wireless at home. So Ethernet cable is 10 times faster. So now we add to that. We keep adding technologies. The next one, we have occupancy sensing. Occupancy sensing is particularly suitable for places like toilets, bathrooms, where people go in and they come out. But the human has a difficulty in operating a simple light switch, and very often they leave it on. So it's very important to, in fact, save that energy, because the bulk of the time, toilets are not and bathrooms are not occupied. It's also suitable for change rooms. So off with a short delay, because you can set the delay on occupancy sensors. Change rooms could also be affected that way, because the staff go into the change room to put their work clothing on, and they go and work. Once they've done that, the change room lights are left on. It's suitable for pause areas. Pause areas where people take a break. Once they've had their break, they get up and they move. The light could turn off. And for meeting rooms, individual offices. Meeting rooms, we go into a meeting room, we have a meeting, we walk out and we leave all the lights on. So with an occupancy sensor, it will resolve that problem. So it's really simple but effective technology to add. We keep adding to it. All right. So we started off with the LED. And so we've gone on using standards, applying the standards correctly, power over Ethernet, occupancy sensing. So let's summarize our savings so far. And please, you must remember, this is not a linear saving. So if you save 60% on your switch from old technology lighting to LED, and then you apply the standards correctly, and you get a 40 to 60% saving by applying the standards correctly, it doesn't mean to say that you've suddenly got 120% saving. It's a saving. Once you've put your LED in, the next saving is a saving on the use of the LED. All right, do you follow? So it's a non-linear progression of saving. Power over Ethernet, you'll get between a 5 and 10%, depending on the type of luminaire or the lamps that are involved. Occupancy sensing can produce around 40% for those areas that are fitted with occupancy sensing. Remember, not every area is suitable to use occupancy sensing. Right, so let's move on this exciting journey. So let's look at daylight calculations. Here's an area that we can certainly save money. And obviously, the material I'm showing you is for South Africa in the southern hemisphere. If you're in the northern hemisphere, it will be slightly different, because obviously you'll look south rather than we like to look north for a sunny environment. And also in the northern hemisphere, you have longer and darker winters in certain parts of the northern hemisphere. If you think about Scandinavia, the Scandinavian countries. So let's work through this. The first we deal with is daylight autonomy. What is daylight autonomy? Daylight autonomy is a calculation that we do to see in any space where we have natural light influencing the space, to see how much the light exceeds the target lux level that we want. So if we're looking for a 500 lux level in a space, we want to see how much more light we get than the 500 lux. And how we get it, how much of it is achieved in a working day. Obviously, these things change for winter and summer. The next one we look at is the continuous daylight autonomy. And that is slightly different. This is where the required lux level falls below the level that we require and for what working hours. Why is that important? Because in the first instance, where it exceeds the target lux level, we can actually do without the electric lights, the artificial lights. But where it falls below, that means we have to turn the lights on. Right. And there are various things we can do for that. And then, of course, in the process, we calculate our daylight factor to see what the daylight factor is going to be. So let's look a little deeper at this. In preparation for this evening, I made up a model in Relux Desktop, and the model is quite simply 10 meters long and 4 meters wide, with windows all on the north face. They're the large windows on the north face. So let's have a look and see what the result was. There it is. I'd set the target data for 500 lux, a daylight factor of 5, 9-hour day, and 5 days a week. And look at the lux levels. If you look at the colors at the bottom, for the daylight factor, this is the daylight factor and not lux levels. All right. And you'll see that where it's this dark purple, that's between 1.5 to 2 daylight factor. The lighter purple is between 2 and 4 daylight factor, and between 4 and 7 in that red color, and between 7 and 12 there, and even higher between 12 and 20 in these areas directly at the windows. All right. So if we have a look at what the data says, the algorithm that we use was average indirect fraction. We calculated an evaluation surface height at 0.75 of a meter, and it was for a CIE overcast sky. You can see the date and the time, the location, coordinates, north angle, it was facing north, and the daylight factor, average daylight factor, was 5.7. The median, it's the average, was 4.7. The minimum was 2, and the maximum was 14.4 daylight factor. So we now have all of the data that we need to continue. Now we can look at the lux levels that we achieved in the same model. And if you have a look on the scale here, the lighter green is between 300 and 500 lux. So in that part of the room, we'd probably need to put the lights on a bit sooner. Then the next shade of green is from 500 to 750. That's this darker shade. Then this darker blue color here is from 750 to 1,000 lux. 1,000 to 1,500 lux. So you can see it's really high when we start getting across here. Again, it's 200 to 300 lux right at the wall. Okay, so this is the effect, and you can see it on the walls similarly, and how much light there is on the ceiling even. And you can see that this wall is lit slightly less, between 200 and 300 lux. Now, quite clearly, if the room is that bright, and you can see it again here in the colors, all right? If a room is that bright, we would have to do something to mitigate for the glare for a start, and shining directly into the room. So we could have vertical blinds. There's a whole lot of solutions that you could apply for that. You could do tinting on the windows from a very light tint to quite a heavy tint, because you also have to think about the R factor. It's the thermal factor, what it's going to do to the temperature in that space. You might have air conditioning, but still there will be an increased temperature. Do you have double glazing? So there are a number of things that will influence the comfort in the room itself. So we're not responsible for that part of it, but we can give input to the design team that we're working with to cater for that, so that the occupants enjoy comfort and their well-being is being looked after. Right, so as you see, we can work through this and we can produce ISO lines. So we can see exactly, graphically, without trying to interpret colors and so on. The lines tell us 500 lux, 750 lux, etc., going right up to 3,500 lux. Right, so we're able to do all of this within Relux Desktop. So one of the first things we do is we have a look to see, what does natural light do for the space? So that guides us towards the appropriate light fittings. It guides us towards the technology that we're going to use, which we're going to talk more about as we proceed through this, to in fact cater for lighting in spaces where you have lots of natural light. So we're also able to look at the economics of daylighting. And you can see that here in January, daylight provides 85% of the light that we need to achieve the target. Why you should be asking, only 85% in January in the southern hemisphere when it's summer and you've got lots of sunlight? It was quite simple. The sun is very high in the sky. Its azimuth or zenith is very high. So you don't get the same effect of the light coming directly into the space. Whereas in winter, as you move towards winter, you'll see it goes up to 98% in March. And from then on, it's 100%. All right. In September, it starts to come down again, goes up a little bit in October, and so on. So overall, for the year, daylight will provide 95% of the light that we actually need. Yes, I do know that some of that light is not going to be perfectly on the task area. So the task area will need supplementation with artificial light. And you'll see we go right down to, what are the daily working times? 8 to 17. What about staff breaks? We factor in all the staff breaks, because when the staff are out, you can save energy. We can go further and we can look at the economics, looking at Isolux curves, and you can see these are the times of the day on this side, and on this side, you'll be looking at where your light is right down very low, 30%, 60%. These are the months, the dates: January, March, June, September, and December. So you can see how the light changes at different times of the year. And that's a cloudy sky. But what about a clear sky? Because very often we have clear skies. And there you can see exactly the same thing for a clear sky. And these calculations are done exactly according to the CIE directives. That is the feature of Relux Desktop. All right. So if we have a look at this, it can be used, daylighting can be used throughout large buildings. We're now talking about Bluetooth mesh. So we can use it in environments with large buildings, different areas, multi-story buildings or multi-levels. It works extremely well where daylight is within the space, and it contributes to task light air levels. We can in fact program it for occupancy sensing, and we can also program it for daylight harvesting. So when there's sufficient light, the lights will dim down, we'll use less electricity with the lights dimming down, and if there's sufficient, it will even turn off. And when the light is insufficient, the lights will brighten up again and they'll return to full operation. It is fantastic technology. We have used it extensively and it really pays off. There's an illustration where it goes through all the different devices in different areas. This is just a mishmash, on a photo. But you can use it through different areas. You can use it for buildings, in fact, just across a courtyard. That's how good it is. Let me give you an example. A factory that we do a lot of work at. We've been working for this particular client since 2021, and we'll still be working for them up to about, at this stage, my projection is about 2026. They manufacture equipment. We have completed about 60% of the factory so far. There are other buildings within this particular client's portfolio that we are also doing lighting design for, and that's going to come off over the next year, 2 years. We've used Bluetooth mesh throughout with daylight harvesting and occupancy sensing, and a percentage of the luminaires are also fitted with emergency control gear. For in the event of emergency, they're able to stop machines, they're able to safely evacuate the area, and so on. This image here is of the final assembly line, and there are a total of 54 luminaires across 3 bays. So it's extremely important because the factory is powered. We get super energy saving because the Bluetooth mesh that we use also provides a monthly report on the energy saving for the month. So we're getting super energy efficiency here at 40% and more. And this is very important because this factory is self-sufficient in terms of energy. They produce their own energy from renewable energy. The entire factory roof is loaded with solar panels, and they have two very efficient diesel generators that they use at nighttime because they work sometimes right through till midnight, and so on excuse me, on occasions right through until 6 o'clock in the morning. For them, they find it's risk-free, it's essential because 90% of what they manufacture is exported around the world. All right, so that's a classic example, and we've done different areas throughout this factory, which has made it very efficient because they all link up on the same Bluetooth mesh. Not different Bluetooth meshes, on the same Bluetooth mesh. So you can add all devices to the mesh: cameras, lighting, CCTV cameras, and all sorts of other sensors as well, including smoke detectors and more. It produces a monthly energy usage and energy saving report. Daylight harvesting is set up according to the target task area light level that is required. Obviously, the task area in the factory varies depending on the machinery that is being manufactured at that time. As daylight fades, the luminaires automatically brighten up to full output to produce the required light level in the task areas, particularly at night time when they're working. So we should be able to state an equation, because you do everything in whatever we do in lighting, we're able to perform, do, and check mathematically. So if we add LED plus power over Ethernet plus occupancy sensing plus daylight harvesting, we get super energy efficient lighting. It's as simple as that. The problem that most people have is they see a technology in isolation. It's LED. Or you can add an occupancy sensor, perhaps, in some places. All right? But not many people take it to the next level, to the next step, to the next step, to be most effective, to get ultimate savings. So, is that the end of the fourth industrial revolution technology? No. And I doubt if what we even have at the moment is all that we're going to have, because certainly technology continues to evolve. New technologies suddenly emerge, which is the exciting part. So we're going to talk about, in the technologies that we've got, we're going to talk specifically about visible light communication and indoor positioning system. But in addition, I draw your attention to AMRAC's Meta Room, which is the ability to scan internal spaces, including the furniture and the fittings, and points of interest, smoke detectors, air conditioning ducts, return ducts, etc., using an iPhone 12 Pro or an iPhone version higher. I have an iPhone 15 Pro Max, and I'm able to do scans of any space but especially where we can't get DWG files, for example. So we can scan the space, including the furniture, including items of interest, light switches, wall plugs, you name it. You can include all of those with this unbelievable software. and it's easy to do. It doesn't take a long time. It resolves it. It goes to meta room. Meta room, there's work that is done. You bring it back and you take it straight into Relux. It saves 80% time. Normally with the Relux, you would first have to build it up, put in the windows and the doors and all the bits and pieces and the furniture layout and so on. It can save us 80% of the time using this amazing Amrax MetaRoom, but it only works with an iPhone, does not work for Android. And the reason for that is the iPhone has a little sensor. And there's the little sensor. It's called LiDAR. It's a LiDAR scanning device, and only the iPhones have it. Android does not have it. And then, of course, we're always thrilled and excited to use Relux Desktop for our lighting design. It's unbelievable software. It just gets better and better and better and better. All right. There's an add-on that's just been released, which is to be able to calculate obtrusive light in the outdoor space. Right. Visible light communication is very interesting. Luminaires form part of your Wi-Fi network. So they act as a point of connectivity. So you can have a sensor which gives you the ability to make your luminaire part of your network, to transmit data, all right, to extend your Wi-Fi network. Especially equipped luminaires for Li-Fi, not Wi-Fi, Li-Fi connectivity, where they transmit data up and down using the visible light spectrum. This is amazing technology. It's very secure because light doesn't go through penetrate walls, doesn't penetrate glass. If you've got blinds on your windows, so people can't link in as they can to Wi-Fi if you've got unprotected Wi-Fi, which you shouldn't have. So it's absolutely fantastic. The visible light spectrum gives 10,000 times greater spectrum than RF or radio frequency spectrum, which is used for Wi-Fi. So it's amazing. And on top of it, it's able to transmit data up and down at the same speed. Anything from 10 gigabytes per second to 100 gigabytes per second. Now, normally you measure the transmission of data in megabytes per second for Wi-Fi. Everybody will tell you everything about megabytes per second. But here we're talking about gigabytes per second. So when moving about the office, obviously, if you're under one light and you move away, you're going to lose your connectivity. So your lighting design will be to make sure that you, in fact, can hand over from one light to the next light, and you'll have continuous connectivity. All right? So you always make sure that you have overlap with the lights so that you get that connectivity. All right, so let's look a little bit closer at it. So if we're using Li-Fi, you have your normal file server or your computer, your connection to the internet, and your power switch goes through your Li-Fi modem. You'll have a Li-Fi, an access point, all right, through the LED driver, through the lamp, and your computer or device has either a dongle. Some computers are now being fitted for Li-Fi, But if you don't, you'll have a dongle, a USB dongle that you put in there, much like a USB stick, which has a photo detector and so on, and it converts it and sends it through. But we'll see that in a little bit more detail in the next diagram. We will see that there's a photo detector. It goes through an amplification and processing uh, device. Then it's received, the data is received, and it goes onto your computer. The reverse would happen if you're wanting to transmit, because it will go up, out to the internet. Amazing technology. And as time's going by and it's becoming better and better and better, pure Wi-Fi, the prices have started to come down from where they were originally. They were originally quite expensive, but now it's coming down. So ideally, you could set this up for your executive suite in the offices of directors, so on, and that would really be tremendous. So the next one we'll look at is the indoor positioning system. We all know about GPS. We understand GPS. We use it. We drive on Waze or Google Maps, whatever it is, to get to our destination. All right. But what happens when we walk into a shop? We walk into a building. Our GPS dies because we can't access the satellites. So we have indoor positioning systems, which is our GPS indoors. Okay. It makes use of Bluetooth beacons or RF tags, radio frequency tags. So you can fit a tag to a chair, whatever the case is. So you can do asset control. Um, it uses trilateration. In other words, it needs 3 points to determine your position. All right. It's ideal for supermarkets, shopping malls, hospitals, airports, museums, galleries, asset tracking, and various other things. In a hospital, they want to find specialist equipment, life-saving equipment, and it was in use somewhere else. They want to find where it is. They need to get it very quickly. Using this system, they can track it and quickly retrieve the device. So it's really very exciting. For example, in Spain, Carrefour's, they have an app that you put on your phone. You can do your shopping list on your phone before you go shopping. And then as you walk into the shop, the beacons and the computer recognizes that you're there. It looks at your shopping list, gives you the fastest route to follow to do your shopping, will advertise products on the way whilst you're going there. And then you have a point where it goes past, it checks that all the items on your shopping list you have actually purchased, you've got in your trolley. It updates your loyalty card. And the next point that you go past, it deducts the money from your bank account. So the Lidl's got it. A number of the big supermarkets overseas have it. And I know that Woolworths is looking at it here in South Africa. So it's smart devices, not necessarily save energy, but it will certainly save people time when they're shopping because they don't have to go and look for the items. It will tell them what route to follow to do their shopping quickly and effectively. Right, in a shopping mall, for example, instead of going to the big device and pressing on the screen like 1,000 other people have done already before you, and then you haven't washed your hands. In times of like the pandemic, you wouldn't want to do that. So instead, you have it on your device and it will tell you exactly where you are. And you can, in fact, navigate as you're walking with it on your device. So it's like Google Maps indoors. All right. So let's summarize. And once again, remember, using all the savings per item does not give you a linear saving. Each one enhances the other to deliver super energy efficient lighting. So, the first instance, we changed old technology to LED and we save between from 60% or more on the conversion. Correct application of standards, we can save more than 40% if we do it properly. Occupancy sensing can save an additional 40% in those areas where you use it. Power over Ethernet can effectively give you about a 5% conservatively. Daylight saving or daylight calculations, if sufficient, can mean that you can save using the artificial light altogether for periods of time, or only supplemented with some of the artificial lighting. And then Bluetooth mesh can bring about additional savings with the daylight harvesting, occupancy sensing, and so on. So all of those things put together make up super energy efficient lighting. Now, I know we've gone through these very quickly tonight. It doesn't tell you the how in any detail. You don't know how to develop the system architecture, because now we're using technology, so you must first design the system architecture before you can actually use it and implement it. So those are things our students learn on our advanced diploma in illumination engineering course in second year. And you can't apply the second year subjects, without a solid foundation of all the theory that they learn in the first year. So once again, thank you very much for attending. It is always a pleasure. And as you know, webinars are free of charge, and we hope that you found it informative. If you want to know more about the courses offered, you can contact either myself, and my details are on the screen, or Daniel, and his details are also on the screen. So we look forward to seeing you again at our next webinar, or the open day, and at our future webinars that we have in the planning stage at this stage. All right. So have a very wonderful evening, nice relaxing evening with the weekend ahead. And I bid you a very good night. Thank you very much.